Stream today and I'm going to continue what I was working on yesterday, which is experimenting with parametric equations of surfaces, sine distance functions for volumes, and a way to represent that concisely in a data structure that I can use to draw 2D and 3D diagrams in the document renderer. So I was poking around yesterday with this. I have as sort of a general test case, or at least a good starting point in my mind. This work tab here, parametric, box and cylinder, I have a starting point there, but I haven't touched those yet. And I have a rotate function, a sort of translate function. I have a boundary rep circle and a sphere. And the sphere is what I was kind of working on a bit yesterday. And I had different sort of rendering approaches, which I think actually I'm gonna split out into separate things so you can see them more clearly. I'll do that for a minute before I'll clean this up just a little bit. So let me split that. There we go. Just clean this out just a little bit here. That works. Intro in the render area. Right, so here this sphere, what should I call it? My sphere here, and here we've got foo. Instead of that, we'll call it sphere points. Transformed sphere points. So translate and then a rotate of sphere points. By that and that. And this is sphere slices. My sphere. And so rendering method 1 that I came up with is, well, first off, let me let's do this. Sphere defs there, dot rendering. So we map dot onto X sphere points, transform sphere points. yeah. And then all I have to do there is split this, take this up, make something here to render the figure out. It's just going to be the dot sphere, dot rendering, straightforward. Okay, so 500's fine, and 200 I suppose, and a scale of 10 seems to make sense. Then you've got, so sphere defs, dot rendering, end that, and now we've got here line rendering or slice rendering. Slice rendering is kind of what it should be called, slice sphere for path in sphere slices. You draw closed path, and then you do the translate rotate of this like that. And then this figure is a new figure, and it just uses only, here let's slice rendering, slice sphere like that, and we'll make this also 500 by 200. Now this should work. I'll find out. If this gives an error, then I mess something up. But it should be okay. Yes, it is. So there we go. So dot rendering, slice rendering is pretty nice, but let's make an indication here. We can actually do two slice approaches. We can do slice in one plane. We could actually do slicing in this way and this way and this way. You can slice parallel to the Z plane, the parallel to the XY plane, parallel to the XZ plane, and parallel to the YZ plane. So that's three different ways you could do slicing, technically. But I'm trying to think if one is equivalent to the other. The easy way to slice, you could do slice sphere A and slice sphere B, and slice sphere B only has one difference, which is the sphere slices themselves. Sphere slices A, which should maybe be down here. We'll actually do it this way. Why not? B. The only difference is V and U are swapped around here, which gives sphere slices A and sphere slices B here. And when I overlay them directly onto one another, it'll look like longitude and latitude lines on a globe or something. At least if it's done right, it should. Yeah, so you'd see that here, which is pretty nice, in my opinion. Now, there's a few things that are obviously not perfect here. Let me double the size here. of the gaps in this one, so that there's less line confusion on this here. But slicing, and hey Lumi, I'm doing well, how are you? What was I saying? These two different sort of render approaches here, they use data in a different way. So the sphere points, it just gets a straight list of points, but the slicing it goes by slice and then gets the points on a per slice basis. Hey, you're doing well, glad to hear it. That's good. I am yesterday and today I'm slowly working on some ideas with changing up the model I use a little bit for doing 2D and 3D render stuff, and trying to sprinkle in a bit of spec here and there just to see if I understand it, you know. So yesterday I have a bit of spec definition here and a functional spec def here. So whether or not it's perfect is another story, which I'm not worried about at this time, but it's kind of neat to be able to try and use stuff in context right away. So that's what I'm working on at the moment. So let's see here. Actually, where I stopped last was this here. And this is a thing that I still don't have a clear best approach idea in my head for how to kind of wrap up in a concise way functions that produce solids and stuff like that. I don't even know if I'm making sense to myself right now. So I have the functional representation of a sphere, which returns a distance. The boundary representation of a sphere, which returns, given when you put two parameters in, it returns a point. And to kind of wrap them together, I had just two ideas here so far. So sphere idea 1, if I give it a radius of 2, it returns a map of two functions, the functional rep and the boundary rep function. But using that seems kind of cumbersome, right? So if I want to run by using the functional rep, I have to call it by A or by frep A or A frep, and then pass it my points 1, 0, 0, or my point there. Or if I want to do brep A, it expects a different number of arguments. Oh, right, so it works, but it seems a little weird. What is frep, brep? Oh yeah, that's a good question. So frep stands for functional representation. And brep is boundary representation. These are in the world of computer-aided design, these are sort of methods for representing geometric objects, typically in a 3D context. So a sphere is a really simple example to work with, but it basically works like this. If I run frep sphere and I give it, let's say I want a sphere with a radius of 2, right? I run that function and it returns to me a function. And so the functional representation of a sphere is a function that returns what's called a signed distance. So this is, if it's not exactly the same, it's similar to SDF, signed distance functions, which is a pretty cool way of doing like cool rendering things. So here, oh, these are just pictures. Shader Toy, I'm not sure if you're familiar with that at all, lets you play around with shaders in WebGL, and it's very popular to use signed distance functions to represent and produce these 3D shapes. And you can sphere march and ray march and stuff like that to get really cool renders with 3D shapes and whatnot. Boundary representation is basically building up shapes and defining them by the boundaries of volumes and stuff like that. So brep is used in powerful CAD programs way more than you wouldn't really hear boundary rep so much in like animation and stuff like that, but it can be used there, I guess. So they're two useful and different approaches to rendering or storing object like 3D geometry information. And what I'm trying to do is just figure out if there's a fairly concise way to kind of wrap the ideas together and pull out the parts that are useful in different sort of rendering scenarios. So what I'm messing around with at the moment is, if I go into the code that's rendering this document right now, I have made a sphere with a boundary representation, which I'm not sure if I showed that. Def A as brep sphere. So A is a function. If I run A and I give it two parameters between, so there's a parameter u and a parameter v between 0 and 1 for each. So if I give it 0.5 and 0.5, I get out a 3D point. So in this case, this boundary representation is a function of two variables that will return a single point, which effectively maps a 2D surface into a 3D space. You can do a similar thing with curves. So you can have a 3D curve that's parameterized on a single variable, where 0 corresponds to the starting position of the curve and 1 corresponds to the ending position of the curve. And so you can make curves and surfaces in this parameterized style, and those equations can help you in a boundary representation to get point data. I'm not sure if any of this is making sense. It's a little bit, I have like an understanding of how it works, but to explain it is sometimes not always clear, but I hope that makes a bit of sense. As for design, you'd probably layer representation as an orthogonal concern. Make two protocols, as brep, as brep and as sfrep, and implement those in builder functions and combinators. The explanation is really helpful. Never heard of it. The shorthand ones. The shorthand. Oh, like, are you referring to these idea functions I had here? Yeah, I'm interested in. Oh, I see. Yeah. So in my research, slowly trying to learn how CAD systems work and are built up and stuff like that, I picked up these short form definitions, or those terms, and forget that they're not necessarily clear. But yeah, if you look up all the papers and stuff, talk about stuff like brep and frep a lot, and I just forgot that that's not necessarily clear up front. So you'd make two protocols and then implement those into builder functions and combinators. Yeah. I do suppose that would make the most sense, right? Because they do start to deviate quite quickly from each other in terms of like the amount of work you have to do to combine them and do more complicated things with them, like unions, for example, in a functional representation. It is just, how does that work again? A union of two functional representations of shapes is you give the functions and you just do the min between the functions, and that will always union the two together. So it's extremely easy to get certain operations from functional representation that are really hard to map onto boundary representation, because if you union two spheres, the single boundary is necessarily defined by some weird intersection curve, and calculating intersection curves can be quite challenging. So it might make way more sense to implement them all separately, so that all the heavy lifting of various operations is done in its own sort of thing, and then you kind of wire it all together as late as possible. At least that's one kind of thought going through my mind. The lazy, or like, I think this is a bad idea, but when I came up with it, sphere idea 2, if I give it that, oops, right? So I like this idea, but I think it's probably dangerous, right? Because it will accept quietly two different argument shapes, right? So you can give it a point and you'll get a distance, or you can give it two parameters and you'll get a point out. And that looked like that was really cool, but I just don't know that it's really smart or safe, because it isn't immediately intuitive. So it was cool, but I'm not convinced that it's the right approach. There's a somewhat conceptual idea here. If you see function names that look like a Cartesian product, but within that group have the same interface, you're looking for polymorphism or some other kind of abstraction. Let's see here. You see function names that look like a Cartesian product, but within the group they have the same interface. You're looking for polymorphism or some other kind of abstraction. And the polymorphism, I would implement that with, you'd use def multi, right? Kind 1 sphere, kind 2 sphere, kind 3 sphere. Screams for abstraction or function composition. Clojure has a bazillion ways to do polymorphism. Actually, yeah, you're right. There's def multi is the one that I've got the most experience with, so that's what popped into my head. But you're referring to here, right? Frep and brep sphere. That's a strong hint that you want to abstract things out, which is a very good point. And something I really do need to get more practice in modeling it all out, right? You'd use protocols for that, a deferred specialization. Let me suggest using protocols to help with abstraction around frep, brep implementations. Multi-methods can work too. What I actually don't know, so I am aware that protocols and multi-methods have a bit of overlap in like the situations where you can use them, but in this kind of situation, I don't know why I would use protocols over multi-methods. I'm not familiar enough yet with the distinctions between them to know which one I should reach for. What I do know is def multi and multi-methods kind of have more built into them by default. There's like more machinery to it. You can ad hoc create instances with protocols, but you can't do that. Def multi is a global concept. Okay. Let me add a little note to this. Multi-methods is a global concept, but with protocols you can ad hoc create instances, which may be more powerful in this context. Example, using reify or using protocol metadata. Right, by design you would want users to be able to provide an frep and a brep inline potentially. Right, that's actually a very good point. A very good point. That's a good point. Thanks. Users may need or may want to use to provide their own brep, frep inline, which protocols are So use protocols. There. A lot of libraries use combinations of both multi-methods and protocols in their APIs to achieve maximum flexibility, like pattern matching and core match. So it's not an either or, really. Right. Thanks for the input. So I've used multi-methods before in some other stuff I've done. I've not used protocols before, so it's probably my understanding of the two isn't like I don't understand both enough to know yet when they all make sense. But yeah, that it seems pretty typical in the Clojure world that it's kind of, there's not often a straightforward yes this, no that. It's always a bit of, well, sometimes this, maybe a bit of that, and you kind of got to get a feel for it over time. Yeah, protocol is an interface. Yeah, so I'm aware of that as a concept. I just haven't used it yet, so my comfort with it is low, if that makes sense. Another thing on the list to learn, and I'm okay with that. Multi-method is a pattern matcher for a particular function specialization. Yeah. So I've seen multi-methods used in the guy who wrote the Go macro had some talks or demonstrations that I watched where he had, I think it was him, he had like def method, and he had keywords, tags like that, and then the implementation that would transform a node of that tag, and then this whole thing was recursive, so you could just add things and always split out on the tag and whatnot. So that's where that's what I'm currently remembering about multi-methods. But yeah, anyway, a pattern matcher for particular, yeah, so the pattern matching element is kind of on the arguments that get put into, never mind. I understand what you mean, and I'm just trying to reiterate things that don't, in less concise ways, which is ridiculous. So I was thinking of, before I keep going with this, there was one other kind of rendering approach I wanted to see if I could test out for a minute, where, so I have this slice rendering thing that renders layer by layer, almost like a 3D print or something like that. So the beauty of Clojure is you could trivially implement a multi-method system or the like yourself with a minimum amount of code, unless you want it to be fast. That's always the little asterisk on everything, eh? Well, if you want things to be fast, well, that's a different story. You're gonna have to do a bit of work differently. But hey, so be it. I won't complain. I love Clojure. So far, anyway. So this last thought I had in terms of rendering approaches, and I just want to mess around with it for a minute, see if I can make something, is quad rendering, where you render not in slices, but you render in blocks like of 4 points. Does that make sense as something useful to do? It might. So if I have let's see. Let's see here if this makes any sense. For T range 0 to 1, and the steps are going to be 100th. Oh. Right? So that's a step. And then the quad itself would be defined as a list of 4 points based off of this single thing T here. So it would be, let me do a, let me see if this is going to make sense to my own brain here. So you've got T1 is going to be T, T2, this let's do U1 is T, U2 is going to be, if I assume a cell that's just even width and even height for simplicity here, U2 is going to be oh, I should maybe do a let here, step be this, let's see if that makes any sense. Let U1 be T, U2 would be T plus the step that's I think that's wrong. Yeah, this isn't correct yet. What I'm trying to do is get something kind of like this. The first quad would end up looking like, I would want it to be, UV would be like 0, and imagine a step size of 0.1. Oh. And then the next point would be, oh no, I want it to start at 0, 0, then I want it to go 0.1, 0, 0.1, 0.1, and then 0, 0.1, right? Because I could do then map Do I have a sphere defined? I forget. Yeah, okay. So I could then do map A onto ASDF, right? No? Oh. Apply. And then, so that would be, those are the 3D positions of the first quad on that sphere, right? So I just want to be able to do that over the whole sphere. It shouldn't be that hard, and my brain's just not connecting to it in an efficient manner at the moment. Let's just see what this looks like, so at least I have something to work with beyond that. V1 will also be T, V2 plus T step. Then this is always U1, V1. Wait, is that even correct? U1, V1, yeah. U2, V1, going this way, then U2, V2, V2, and then U1, V2. Okay, so that would be a single quad path. Let me see what happens. Oh, don't need to call it, it's quad paths. Thousand. First of quad paths is just a list of 4 points, right? Start with fewer things. If I quad sphere is just going to be map. Since the quad paths is in theory just a list of paths, I can map closed path onto, onto paths, quad paths, and in theory get a result out of that. Quad sphere is my brain even working correctly today? I'll find out. Doesn't feel like it entirely. So there we go. It rendered something. And so all of my, of course, the problem there, and that's a silly one, is I didn't actually, before I map it onto a closed path, I'm supposed to actually map it through the sphere. So I have to turn it into this map closed path of my sphere which is a boundary rep which takes apply my sphere to this map this function onto quad paths to get real paths, right? Let's see if that makes any sense. All right. Okay. It's a slow day for me today. I hope that's all right. They're not all winning days. So my sphere, right now I'm trying to pass into it a whole list, so I need, that's not what I need. I need what's a better way to quads def quad paths, right? I'll do that. I'll map. So let's go here. Quads, define that. First, quads looks like this. It's a vector of UV, of 4 UV coordinates, right? So I could actually, just for fun, do a little sdef quad is how did that look? Tuple losing track of myself here. That seems like a, I wonder if there's like a more concise way to do that, but regardless, let's just test that for a moment. Quad 0, 1. Oh wait. Oh, that my spec is wrong. It's not correct. It has to actually be, right, if I imagine that this is what I'm trying to validate, this is going to be false because it's not, it's obviously not correct. What would I call a UV pairing? Let's surface well, the way I've been building this up, the assumption for a moment is parameter for parametric equations is number number and greater than or equal to 0. I don't know if this is correct formatting. Is there a concise way to write this? I don't know. I'm gonna find out if this even works before I get ahead of myself. I don't think that's right. Yeah. Parameter 0.5 false. Okay, so this is not that's not the right way to write that. Less than or equal to 0% 1. Oh, I always forget you can do it. Oh man, sweet, that's a little helpful there. I always forget that you can do that. Good to know. Now, is it actually going to be right? Oh, that's the wrong thing. Did I type it properly? True. Okay. So 1 is true, 0 is true, negative 0.1 is false, and 1.1 is also false. It's the best feature of Lisps. All the other languages miss that. Yeah, so there's like, I love Clojure a ton, and every time I find myself writing something like what I was doing earlier, less than, equal to, greater than, equal to, part of my brain thinks, I bet there's a thing in Clojure already that makes this way simpler, but I don't know how to seek out those changes, you know? Like there have been things that you've mentioned in the chat on stream to me already that, like, it's a function that is so obvious and I totally didn't know it existed, and I still find myself running into that a lot. I wonder if I have to just like commit the core library function names to memory, like in a repetition, like a cue card system or something. Talking with others, pair programming, or reading the dictionary and reading lots of other people's code is how you get better. Reading the dictionary is like reading Clojure implementation. Yeah. Yeah, so you've mentioned reading other people's code before as well, and there was a library I read through this before because I'm into CAD and stuff like that. This is a DSL for a program called OpenSCAD, and I read through this before, and I remember at the time I didn't take notes on it, so I've forgotten basically everything. Where's the, there we go. But I read through all the source, and it was extremely cool to figure out how someone else did it. Here's an example of what I was referring to earlier as well with def multi and the def method, where they use a key as the matcher, basically. Anyway, so you're totally right. Reading through other people's code, I've done it before and I loved it, and it's I just got to go back and do it more and more. There's a list of I think the next thing I'm going to do in terms of reading when it comes to program stuff is go through the list of dependencies that I use for all my little experiments and get the code for each of those and kind of read through at the very least those libraries so that I know a bit of the machinery for those too, you know? That seems like a good place to go for reading as a starting point. Right, so parameter, and then there's this idea that I've got right here, which is just parameter. It's a pair of parameters, but I don't know what to call that. Surface parameter? I'm not sure that that makes sense. As a name, but the name can change if I need it to. Let me just see if that surface parameter, if I wrote that correctly. Surface parameter. What would be an example of it? 0, 0 would be valid. That's true. 0, 1 would also be. 0, 1.1 would not be. Okay. Oh, I can also, what was it? Exercise. Surface parameter? Is that true? I can. As a really weak manual test, I could just visually, yeah, they look, yeah, that looks about right. Oh, -0, that's weird. Okay, I'm getting slowly a little bit better at understanding when spec becomes a useful thing. So I gotta celebrate little progress for myself, otherwise I'll never get anywhere. Okay. I don't know. I'm wasting too much time formatting things. It's not. I don't need to do this. I'm wasting my time here. Okay. There we go. So Lumi, you're going to say a few times, looks really weird. Someone not using power edit or power infer. Yeah, so I know that those tools exist and I know that they'll make me better, and there's just this part of me that is just like, nah, I don't need to. It's completely irrational. I'm not defending it. It's just I've simply not used it. That's the complete extent of why I don't use it, is I just haven't. And I keep not setting it up. So I have tried par infer a little bit, especially for math expressions. Yeah. So it boils down to well, so here's the story of the last time I tried either of these, par infer and par edit, was when I was still quite fresh with using Emacs at all. And so I was trying to type out a function, like an expression in Clojure, and I forget which one it was par infer, par edit, and I wasn't, like, I just was confused. I wanted to manually type a bracket or a paren, and I wanted to delete one, and it wasn't doing what was intuitive to me at the time, and So I decided to abandon that because I still had a lot to learn in terms of how to use Emacs reasonably well at all. And I haven't returned to it. This is not an excuse, that's just the story of how I'm here without using those tools. The other thought in my mind is it hasn't been enough of a pain, so I also just have been lazy to not do it. Take the time to learn this properly. But you're completely right to point out that it's weird that I don't use it, and sooner or later I've got to get off my lazy butt and just get used to it. Okay. So quad is a tuple that's 4 numbers. Surface parameter. Yeah, it's conceptually just, you should never have to manually indent or format anything with those tools. So that's the benefit. But it does require some dedicated learning and some time for muscle memory to set in. Yeah, and I just haven't set aside that time yet, that's all. But so I'm not sure which tool it is, paredit or parinfer. More and more I understand the benefit of it, where you can like, is it like, it's like barf, I think they call it, where you could like hold a certain key combination and press the arrow keys, I think, to like shift something in or out of a set of parens. Like, so you can increase the nesting of an expression or decrease it or something like that. Whichever tool has that seems to be the one I'll probably like the most, because it seems useful. Unless they both do that, I don't remember. There's other ones too, Lispy, Smart Parens, paredit, parinfer. Oh, they all have slurp and barf? Okay. I don't completely love, like, they're funny, slurp and barf, but I don't completely love it, because it's hard to take seriously someone who's just like using those terms just willy-nilly like that, but it's all fine. I mean, there's also, when it comes to files in Clojure, there's spit and slurp and all that kind of stuff too, so a little bit of silliness exists throughout. Okay, quads, quad paths. Now this is right, quad paths would be mapping what am I doing here? Okay. Quad paths. What was I trying to do here? Ugh, jeez. My brain, where's it at today? Okay, quads is a list of vectors, so a list of paths basically. Oh, I should, before I forget that, sdef path is a path has to be, this is the wrong spot to define that for right now. I'll get back to that though. Specs to add path, essentially a list of points Wait a minute, sdef, there's an easy way to do that. If it's only a list of points, path is just s star point, I think. Let's see. Yeah. So, valid path first quads true. So one, that's potential issue. Quad is indistinguishable from point 2D because they are both just tuples with numbers. So that's a potential ambiguity, which I'll deal with another time. Let's just get rid of that note. There we go. Have to go to the washroom for a minute. Be right back. Shouldn't be long. Wonder why I use tuples at all. Why not use a record or a map? I have to go to the washroom, but I'll talk about that in just a moment. They're faster sometimes. I'll be right back. I won't be long. Just gotta mute. All right, I'm back. So why am I using tuples? Why not use a record or a map? So the reason, for example, that I don't use a map, say, for defining points or quads is, as I've been building this stuff up, I've been making just test shapes and stuff automatically or quickly, and I've literally just been making points like this, and it's faster, or it has been faster for me to just use vectors just like this, and I hadn't given it much thought beyond that. That's the real and whole reason why I'm using tuples. Tuples? I don't know how it's pronounced. But like, so if, for example, I had defined example point as a map with keys x, y, z, right? It's cumbersome to, if I'm just typing up test data quickly, it's cumbersome to write out maps. It's faster for me to type points just like this. That's the whole reason though. If in terms of like effective architecture of the whole thing, it actually makes sense to use records or maps instead, that would be something that I do when I've got a clearer architecture to work from anyway. I think I'm going to digress for a moment. I think :Z in messages turns into a face. That's funny. Let me see. My computer will send a message one day. Yeah, that's funny. That's a complete distraction. Record you would be able to type as hash record 123 rather than, yeah, it does. Clojure REPL doc def record. Oh man. TLDR. Well, I can't complain that they don't have documentation. They certainly do. So one thing, Lumi, that I've got in the back of my mind for building out a library is, and maybe this isn't like the quote-unquote professional way to do it, but I am trying to iterate on the ideas so that I can use those ideas to build out a better architecture, and then use those ideas and that set of code to produce a useful output. In my case, documents with CAD data in them and diagrams. Then, having learned by producing an output from the library, I can then go back and add in more effective and efficient structure over time. So I use tuples because they're the thing that I know exists and works the way I want them to right away. It might be true, and you might be totally right, that something like a map or a def record would be faster, and I'm not opposed to using them. It's just that I haven't used them yet to build up the ideas, right? Yeah, there isn't really a right way for experimentation, especially. Yeah, so a lot of the things you bring up are, I'm sure they're true and great ideas, and I just don't know when I'll be able to roll them into what I'm working on, you know? Personally prefer things to be as maps when I experiment. So I think that makes a lot of sense. One thing def example edge. One thing I've been thinking about for representing things beyond just points is, say, edges, for example, right? Where you could have an edge could have the function, it could have attributes like color, line thickness, or whatever, if you want to consider that, and then nodes or something like that, which would then, the nodes might be a list of tuples. Anyway, point is not that I know specifically what I would put in there, but using maps seems like a reasonable way to start defining things that are more advanced than just points. The reason is to be able to add stuff ad hoc easily. You can't do that with vectors or records easily. Then later I'd add records, or when I need nominal identity. Example for protocols. Right, that makes sense. So this is just a curiosity. Is the implementation for vectors very different than maps? Because I know you can almost pretend that a vector is a map where the indices are the keys themselves, right? So like the semantics of a vector are similar to that of a map, but I wonder if the implementation is very different or not. It is different. That does make sense. It was just a curiosity. I kind of think for something in terms of geometry, for something as fundamental as a position in 3D space, I think using a tuple kind of makes sense in that instance. But using maps really starts to make sense when you're building up from that. So a point is just a list of 3 numbers, x, y, z. An edge is a list of points and some function that connects them. So it could be just a straight line equation, or it could be a Bezier curve or something like that. And so already there you have different types of information that are useful to build up the shape. So even that, it starts to make sense already to use maps. But I kind of feel like at the fundamental level, your nodes or your points in 3D space make a bit of sense as a tuple. But I am not dogmatic about that. I'm willing to change things if and when they make sense to. The problem is the ambiguity for things that are not points. If you had a type system, the approach would be fine. Right. Yeah, that's a completely fair point, and it is something that is as of yet unaddressed. And I have a note right here already about ambiguity in the spec. But you can use clojure.repl/doc def_type. Wait, def_type and def_record end up being, I think people always recommend to use def_record, but less often to use def_type, something like that. Anyway. Should I introduce a type system, handle ambiguity between example quad and point? Alternatively, you could use maps for everything and avoid ambiguity via tags or other data that you can add in there. Def_type is for Java interop. If you need a mutable cell, def record. Oh, if you need a mutable cell. Def record acts like a Clojure map but is faster and has fixed fields and a unique type. That makes sense. Right, so it makes sense for the context of, hey, Inpermikov, how's it going? What is the idiomatic way to type tag vectors of numbers as points, for example? Hey, glad to hear you're doing well. That's nice. Thanks for tuning in. Don't let me interrupt any questions you guys have amongst each other, of course. I'm just kind of having a slow, chill day here anyway, so no worries. Okay. So the quad paths, right? I'm just going to map the mySphere function onto, for path in quads, map mySphere onto path. That should work. Oh, whatever. And then here, def example point as a map. You could just have a key tag and then the value is point, just like that. That's exactly what Lumi's saying, right? Yeah. Point 3D to be more specific, and then you have your x values, whatever they happen to be. And then if you do def record, name and fields, and options and specs. So the name would be def record example point, and then fields, right? You can just do tag X, Y, Z, I think. Oh, it's got to be a vector. Fields must be symbols. Well, okay. They have to be quoted. What am I doing? Clojure.repl/doc def record. Pull it up here, see if there's a bit of an example just for a minute. Fields, options, specs. Load namespace. Def record example point. Oops. This doesn't, I'm not sure that that works. I feel like I'm missing something here. What? Oh, maybe, well, let's see, X, Y, Z. Okay, so then, example point, you could type it out by record hash example point, and then as if it's like a vector, 1, 2, 3. Oh, I forgot the tag. Oh, but in the case of a record, it wouldn't really make, you kind of don't need the tag anyway. So if I do that, example point here, no reader function for tag. So I didn't define a reader function at all, but okay, that's theoretically fine anyway. Well, okay, whatever. Okay. So the quad sphere would just be map closed path onto quad paths, I think. I've done something horribly wrong. Okay. What am I even doing? What am I doing? My sphere. Oop. Quads is fine. Quad paths. Oop. Let's have a look. Quad paths of, well, sorry, I meant to take the first from that. Quad paths. Wrong number of arguments passed to brep sphere. Okay, so I'm making incorrect assumptions already. First of quads is that if I map my sphere onto that, doesn't work, but if I map, oh, is it because I have to do an apply my sphere, there we go, apply my sphere onto the path, so that's quad paths. So now first of quad paths looks like a path 1, 2, 3, 4, yeah. And then a quad sphere is map closed path over all the paths, and in theory that will actually render out in a moment if I fixed it. Still what have I done? Closed path does take a list of points. First of quad paths it's not a function. Yeah, so if I do stylo.draw slash closed path, of this, so it can render a path out, which is good. I've become lost in my own progress today. I wonder if my crappy builder thing chokes on this, on the SDEFs. If it does, that's a bit of a problem. I don't know what I've done. Let's clean this out for a moment. Let's put these up in a spot that, oh, Nope. Move that. Okay. Specs. There, and while I'm doing that, let me move these also up here, just to consolidate for the time being the definitions that I'm using. Maybe fdef should be by its function though. Ooh. Okay, we'll call that saved for now. So that's at least, the specs are at least in a spot that I'm not gonna delete, because the doc part here is kind of ephemeral. It's just a scratch pad anyway. So if I comment out all of this stuff, can I get back to a point where the document's actually rendering? Or did I mess something up along the way? Well, now I goofed. Okay. Wait a minute. This has gone off the rails for me. I'm sorry about that, but I don't know what's happening, so I'm trying to get to the bottom of things. Maybe I'm missing something obvious, but okay, so I'm in the builder. Markdown to page of slurp param.md. Okay, I've got a problem here. Oh yeah. How do you unbind again? Clojure unbind symbol. I forget this. There was a ns unmap. I think that's what it was. If you pollute your REPL a bit, you may want to undefine some symbols to prevent so to do that, you can unbind it's not unbinding this is, I believe, what I'm trying to get at here. Let's see if that's correct. So let me go namespace unmap the namespace parametric and the symbol my sphere. So now, is that what it was? What have I done or haven't done? Quad rendering. And if I go parametric specs, I think I forgot to tangle it. Tangle param.clj should work. No such namespace S. Yeah, okay. Oh boy. Oh, specs, the order of that's wrong. I accidentally put them above the namespace, so then when they got tangled, they were all defined before the namespace declaration. So there we go. Finally, have something to see again. Okay. That took me a little longer than I would have hoped. But well, that's not right. And the reason it's not right is because I'm not thinking it through correctly. So what do I need to do here with okay, first of all, let's go in here. So let me make this step, let's just make this bigger, and so we can see what the step looks like when it's a little larger. I'm looking at this down here, by the way. It doesn't look like anything. 0.05. I also so this first of all, this is incorrect, right? It's not. It's basically just making a ring, a band of quads around one section. At least that's what it looks like here. And what I actually need it to do is for the parametric. So there's the parameter space of the sphere surface I have is defined by two variables u and v, and so if I discretize, it's u can go from 0 to 1 and v can go from 0 to 1 in the other direction. So if I discretize that into let's say 100 cells in total, that means the step I need actually like an nx and an ny, right? So number of x, let's make it 10, 50. Number of y will make 50 as well. And then that, so each of those cells, every single one of those will have 4 points on it, right? Where the step for each of those points is defined by its, well, the step size is going to be why is this so hard for my brain right now? I wish it wasn't, because it should be fairly straightforward, I think. Okay, so I could well, okay, and x, let's assume 100, and y will assume 100, right? So the total, well, then the step, well, no, if I do size 100, that means the x and the y will make the same size, at least as a starting point. Is that the smart thing to do? The step, the total step for a single range. Oh boy, this is just not my day. Not my day for thinking. So we've got for t, and that's making one band of these. But to do Ugh, my brain is getting nowhere today. I'm really sorry about that. It's just a complete brain fart on my part right now, and that's not very elucidating. So the idea I have isn't working. Or let me see, maybe if I can do something like, so if I can do def UV grid, something like that, as a, maybe I can wrap my brain around something if I visualize a little bit easier. If I do a UV grid is map dot, the dot function, which I have here, onto a grid is just going to be for range 0 to 1, step of 0.01, u is that. I'm not even writing full functions anymore. There we go. And v, range 0 to 1, 0.01. So it's an even grid there, and then the result of that will be let's space them all out. I've got times 20 map v, I'll just be lazy, 20 no, we'll do map v onto UV. So there's a grid, and UV grid is map dot onto grid. UV grid. Oh, did I leave unfinished things here? Let's get rid of this. Step 0.01. Man, I hope everyone else is having a better brain day than I am. I thought I'd be firing on all cylinders today, but unfortunately that just hasn't been the case. So I do apologize for that. Not my brightest hour. But at least I'm drawing something in on the screen again a little bit. So let me just space it out like that. Pardon me. Okay, so we've got grid points to work from. I want to see if I draw a closed path over, let's do first of partition by 4 the UV grid. If I do that, so what I think that'll do is just draw a straight line here, like on the first 4 points, which is not actually what I want. I want it to be on, oh, is it even going to work? Yeah. I don't see any change. Parametric. Oh, this has to just be grid, not UV grid. So what I expect when it finally is drawing a path is that it draws it on the first 4. Oh, it did draw it along the first 4. It just, I was pointing to the wrong corner. But I need it not to do that. I need it to go 1, 2, 3, 4 like that in a square, right? And that's the part that I'm sure is easy, and I'm just not thinking of it properly. That's the thing that's messing me up at the moment. So, oh, the grid's a little cut off too. Let's do 250. Just there, just because. Okay, so if I do okay, I have been staring at this for long enough and not actually getting anywhere effective. I know that if I step away and come back to this with fresh eyes and a fresh mind, I'll actually be able to get through this. I don't want to sit on stream just frustrating myself. And I've been going for 2 hours today, I'm a little tired, and this isn't going to be entertaining at the moment, so I think it's probably the best for me to stop my stream now, go take care of myself, go on a run, go on a walk, get back at this, and have a game plan for tomorrow's stream so that I'm more intentional with what I want to be doing for the day. I'll have more solutions prepped and ready to go, and I'll hopefully sleep better tonight so that my brain works. So on that note, I am gonna shut it down for the day because I'm gonna step away. A little less happy with how things went for today. Yesterday I was pretty pleased that I managed to start writing some actual specs, get some test work done for FREP and BREP stuff, which is, I think, a really promising approach, one I'm excited to keep exploring. Today, less effective, but not every day is going to be a good day, and ultimately being okay with that fact is probably a good thing too. Thanks for tuning in, and thanks for chatting, people who did so. If you're watching this at any other point, thanks so much. Despite today being a little slower, I am legitimately excited to be doing this, and I am going to keep it up. At the end of this week, I'm going on vacation for a bit, so I can't stream every day. But once the vacation's done, I will have a firmer understanding of the kind of show I want to be doing here, the specific work I want to do on stream and off stream, and a schedule that makes sense for me to sustain and deliver nice content. So soon enough, this will be wrapped up in a little bit more polish, and I'm really excited to get all that stuff going. So anyone who is tuning in at all and is interested to see where this goes, stay tuned and feel free to engage and talk to me about what kind of stuff would be cool to see, where I can improve in terms of the stream, and just grow with me on that. That would be really cool. So all that aside, I hope everyone has a good day. I hope things go well for you. I'm gonna shut it down for the day and get some rest because I'm gonna need it. I'll be back again tomorrow. Have a good one.